So I'm going to go through the solutions to this. This is the marking scheme, but some of the questions came from the book, so the marking scheme isn't going to be a huge amount of help. Right, so this one. The question was, the sun loses 4 million tons of its mass every second in a process of producing energy. Work out the loss in mass of the sun in kilograms per year. And then it goes on to say, give your answer in the form. And it says, all this stuff, which we know means scientific notation. Yeah? Okay, so 4 million tons. Sorry, I am writing this. Give me a sec. There you go. So 4 million tons per year. And we want, it says there, kilograms. Oh, sorry, that's wrong. It's 4 million tons per second. Isn't that what it says? 4 million tons of its mass every second. Okay, so it says a ton is 1,000 kilograms, and we want it in kilograms. So we're going to go over here, and we're going to multiply this by 1,000, which will give us 4 billion. 1, 2, 3, 1, 2, 3, and that is kilograms per second. Yeah, so all I've done there is change the tons into kilograms, and we were told there's 1,000 kilograms in a ton, so I just multiply by 1,000. Okay, the second one we need to convert is a bit harder. We need to convert the seconds. Okay, so you have to kind of go up through the stages. So you ask yourself how many seconds in a minute, and it is 60. So we're going to multiply by 60. Sorry, just getting my calculator. So I get this. It's exactly read off my calculator, and that is kilograms per minute. All right, then we go again, and we want to get minutes to hours. So it's 60 again. That is 1.44 by 10 to the 13 kilograms per hour. The next one up is days, and there's 24 hours in a day. So we'll multiply by 24. So that is 3.456 by 10 to the 14 kilograms per day. And then days can go straight to years, and it says here they're 365 and a quarter. Sorry, is that 365 or 364? No, 365 and a quarter days in the year. So I'm going to multiply this by 365 and a quarter. So multiply by that, and I'm getting 1.2620304 multiplied by 10 to the 17 kilograms per year. Okay, so let's see what they wanted. Kilograms per year, scientific notation, which I have, and then the last thing, which I didn't highlight the first time around, is the 3 significant figures. Okay, so significant figures, we start counting at the very beginning. So that's the first, that's the second, that's the third, and then we want to put in a stop. We look after the stop and we ask ourselves, is the 2 strong enough? It isn't, so the 6 won't change. So I just drop these numbers, and I get 1.26 by 10 to the 17 kilograms per year. Okay, so that is how you do that one. There was 10, you can see here, there was 10 marks. Sorry, I'm just looking at the answer here to make sure I'm right. Why am I... Oh, wow. Sorry, this answer is wrong. You can see here they say loss in mass kilograms per second and they have 4 million. It wasn't, it was 4 million tons per second. So this sometimes happens in a mock paper. So my answer is right and this one's wrong. That's fine. So yeah, 10 marks if you get it all right, and that's in line with my answer. 7 is for a high partial credit. So that's if you do part of it correct, and it describes it over here. And then 4 marks for a low partial credit. And it gives you examples of what a low partial credit looks like. All right? Right, part 2. The energy produced by the sun is given by the formula E equals mc squared, where E is the amount of energy produced in joules, m is the loss in mass of the sun, and c is the speed of light emitted from the sun, which is 2.998 by 10 to the 8 meters per second. Write out the amount of energy equivalent to the loss in mass of the sun in 1 year. Give your answer in, and once again, it is give your answer in scientific notation, and this time it's 4 significant figures. Okay, so we just follow the formula which we were given. Sorry, this is question 1, part 2. So the formula is E equals mc squared. E equals, so m is the number I got over here, so 1.26 by 10 to the 17. And then the speed of light was 2.998 by 10 to the 8. And then we want to square that. So yeah, this just goes into your calculator. So I am getting 1.132488504 by 10 to the 34. We want 4 decimal places, or no, we don't. We want 4 significant figures. So start at the very beginning. 1, 2, 3, 4, and stop. Is the 4 strong enough? It isn't. So we just lose these numbers. And it's 1.132 by 10 to the 34 is the energy. And I think the question said it was going to be in joules. E is the amount of energy produced in joules, so we don't need this, but J. Okay. I assume if the paper got the first part wrong, they got the second part wrong. Yeah, they still did their value for mass. That's fine. And I did mine, so, and then we both did the 2.998 squared, and they're getting the same thing, 1.132, but they're still out by a factor of 3. That's fine. So again, that's 10 marks, 4, 7, or 10 up for grabs. The next one then, this is B. And it is 3 to the 2x minus 1 equals 27 to the x plus 2. Okay, so I was just taking that down there. Now, so you will notice that on both sides of the equation there are x's, which means we can't type anything in. So we're going to have to break it down. Okay, so the first thing I'm going to do is break down the 27. So 3 to the 2x minus 1, and we change this into 3 cubed, and then we still have x plus 2 on the outside. Okay, so this remained the same. This remained the same. And this remained the same. The only difference was I changed 27 into 3 cubed. Okay, so here I have inside and outside the bracket, so I can multiply. I don't know if you remember how to multiply a 3 by a bracket, but you do it this way. Okay, so 3 to the 2x minus 1 equals 3 to the 3x plus 6. Now, according to this, those two things are equal. We can already see that these are equal. So then these must be equal. So we take 2x minus 1 and we let it equal 3x plus 6. We are going to isolate the x's, which means we have to gather them. So at the moment this is a plus 3x, so I get rid of that with a minus 3x. And then over here a minus 3x. So tidy that up. This there is minus 1x. This minus 1. That side is 6. I'm going to get rid of the minus 1 next. I do that with a plus 1 and a plus 1. So minus 1x equals 7. And then I'm going to isolate the x by getting rid of the minus 1. They're stuck together, so I get rid of the minus 1 by dividing. Divide by minus 1 and check it on your calculator if you need to. 7 divided by minus 1 is minus 7. Oh. Another 10 points there. This time it's 4, oh that should say 6 for the mid partial. Four, 6, 8 and 10. Okay, n is a set of natural numbers, z is a set of integers, q is a set of rational numbers, or is the set of real numbers. Excuse me. The sets shown are in the Venn diagram. Write each of the following numbers in a copy of the Venn diagram below. Okay. So I literally just typed these into my calculator. I could probably fit them up here. So 2 cubed, if you just type it into your calculator, is 8. If you type minus 1.75 into your calculator, it gives you minus 7 over 4. If you type sine 30 in, it gives you a half. 3.2 by 10 to the 2 gives you 320. 5 by 10 to the minus 3 gives you 1 over 200. And the square root of 3 just gives you the square root of 3. And if you know your sets, you should know where they go. So this is natural. So I'll pop that in there. This is natural. This, and this is rational, or they're fractions. So 1 over 200 and a half. Yeah. Generally speaking, when you put these in, you should put them in using what you were given rather than what you calculated. Do you know what I mean? But it doesn't matter. Okay, and then the last one, square root of 3. When you do it on the calculator, you don't get a fraction option. So there is no fraction option, and if there is no fraction option, then it has to be irrational. There you go. Does that make sense? So that one, oh, hang on. Yeah, that one is worth 12 marks. So it is 2 marks each. The previous one was 30. All right. Okay, question 3. Write each of the following as the following pairs of numbers as a product of prime factors and hence find the HCF and the LCM. Okay, so the first thing here is prime numbers because you need them to divide. So the prime numbers are 2, 3, 5, 7, 11, 13, 17, etc. We take 240 and we're going to start with the 2, which gives 120. 2 gives 60, 2 gives 30, 2 gives 15, 3 gives 5, and 5 gives 1. So that is 2 by 2 by 2 by 2 by 3 by 5, and then shorthand is 2 to the 4 by 3 by 5. Okay, the other one is 280. So that's, that's 2 is 140, 2 is 70, 2 is 35, 5 is 7, and 7 is 1. So that is 2 by 2 by 2 by 5 by 7, which is 2 cubed by 5 by 7. Okay, so generally speaking, we get the highest common factor from this line, and we get the lowest common multiple from this line, but it's not that straightforward. Sorry, so the top line, highest common factor, bottom line, lowest common multiple. Okay, so I find a pairing, and I put it into the answer once. I find a pairing, put it into the answer once. I find a pairing, put it into the answer once. There's another one. I find a pairing. So put it into the answer once. So that is 2 by 2 by 2 by 5, which is 40. Okay, and then the lowest common multiple, we'll use the second line. So we find a match, and we take the higher power, which means you're going to take this one and eliminate this one. So that is 2 to the 4. Find a match, take the higher power, so they're both the same. So just take one of them. And then multiply in any spares. So I have a 3 and I have a 7. So 2 to the power of 4 times 5 times 3 times 7 is 1680. Yeah. Question 3 is worth 20 marks, so 10 each. Question 4. 7 to the 2x plus 1. Now there's a chance this thing might work because it doesn't have x's on the far side. It doesn't work. Ah well. So I need to write that as a power of 7. So 7 to the power of 3 maybe? Oh, that worked. So that's 7 to the power of 3. Now the bottom line. So I'm just going to change this, which means I'm going to leave this bit alone, and a square root changes to a half. Yeah? Sorry, it should be in pink. Okay. So then I have 7 to the power 2x plus 1 equals 7 cubed, and the bottom line is a brackets. So I can do a half multiplied by 3 and get 1.5. This is a division, so it becomes a subtraction. So 7 to the 2x plus 1 equals 7 to the 1.5. Now this says they're equal. These are clearly equal, so these two must be also equal. 2x plus 1 equals 1.5. We're going to try and isolate the 1. So minus 1. 2x equals 4. And then divide by 2 to separate. So x equals 2. And that is where am I? Sorry, I'm trying to figure out if I took this down wrong. I got a different answer here. 1.5. Oh yeah, sorry. This is definitely wrong. Sorry. Here. I don't know what happened. 1.5 minus 1. So this calculation here. Oh no, sorry. Oh, that's really annoying. Sorry, I forgot to move the thing on. Anyway, the yellow one became 7 cubed. The pink one became